All right, this section is transformations for Algebra 2. What we're going to talk about are the parent functions in this video. So these are functions that you're going to have to know how to graph by heart. So make sure you know how to do these. There are 7 of them that I'm going to make you remember how to do here. The first of which is our basic one, y equals x. Now for each of these functions, we're also going to find the domain and range. But first, let's go ahead and let's look these over. So I'm going to start by putting in my table. If I have my x values here, and I picked my x values in a certain way, but for y equals x, it's really easy. My x values are going to be the same as my y values. So if I plug in x equals -2, my y is going to be -2. If I plug in -1, y is -1, 0, 1, and 2. Now what I have to do is I have to go graph all of those points. So I'm going to graph those quick for you. And then we draw a line that goes through each of those points. Now we're sketching here, so this doesn't have to be perfect. As you guys have noticed from other videos I've done, I'm not a wonderful artist. All right, now domain and range. What domain and range means, that means what are my inputs and what are my outputs? What are my possible values that I can put into there, my x values for this? What are my possible values that can come out of it? So really what we need to do is we need to look at what x values can I put in. So I'm going to look at my x's here for my domain. What x's can I put in here? So I'm going to look left to right. Is there anywhere that I can't go? Well, no. I can go all the way left infinitely long, and I can go all the way right infinitely long. So there's 2 ways we can write this. We can write all real numbers, and it looks like that, kind of an R with a next little dash next to it. Another notation that you might see is -infinity to infinity. Now I don't put brackets, I put parentheses because I can never actually reach those infinities. So I'll show you in a second what I mean by that. All right, range, what we're going to look at for range is we're going to look at our y's values. So is there any point that stops where I can't put any more y's in it, or is there a hole in there somewhere? Well, no, I can put in any y I want. So again, it's all real numbers, or it's -infinity to +infinity. Now I myself, I like this notation better, so I'm going to do that for the rest of the video to show you guys what I mean. Some people like the all real numbers. Really, just do what your teacher wants you to do, which one they want you to do. All right, now we're looking at x squareds. And again, I picked certain x squareds in here. So really when we plug these values in, x squared, -2 squared is going to be 4, 1, 0, 1, 4. Remember when we graph quadratics, they should be mirror imaged of each other. So I'm going to graph those points and then graph the line. And by line, I do mean the parabola for this one. And now we're going to look at our domain and range again. So again, domain, are there any x's here, left to right, that I can't put in? Well, no, I can put them all in, so I'm going to do all real numbers, or -infinity to +infinity. All right, now we're also going to look at our y's. And now, if we look at our y's, we can't go all the way down, can we? We stop at a certain point here. So now I'm going to show you the other notation first here, and you guys can look. The first notation is, well, when y is greater than or equal to 0. That's all the y's that we can put in. Now, the way I like to do it in this same notation like that is I know the lowest number I can go is 0. The highest number I can go, well, it's going up infinitely long, is infinity. Now, when I can actually equal that 0, I put a little bracket. And when I can't actually get to that infinity, that's where we put the parentheses. So this is the notation here that I'm going to do for the rest of this video. Some teachers will use this notation right there. All right, now let's go to the cubed part. So again, I picked certain numbers that I'm going to plug in there. And again, we're going to plug in our x's for our y's. Our x's to find our y's, we'll get -8, -1, 0, 1, and 8. And let's graph each of those points and then graph the line. All right, and that's the curve that's going to make. So make sure you guys check your work. Make sure you got your lines on there. Now, I just extended my line up a little bit there to get to 8 on my graph. Some teachers are okay with that. Sometimes you'll have to go by 2s on your scale. Make sure you ask your teacher what they want. Now let's look at our domain and range. Now this one's a little bit trickier to see, but if I go left to right, is there any place where I can't go? Well, no, I can go to any point there. Those are going to go infinitely long forever, so that means I can do them all. So -infinity to infinity. My range, remember my range, I'm looking at my y values. Are there any y's I can't do? Well, that one's easier to see. Nope, I can do them all. All right, now what I want you guys to make sure you remember from these pieces is, first, what the graph looks like. What do each of the graphs look like? What are my x values I'm putting in here to figure out my y's? What are the y values that are coming out from my parent function? And last thing is your actual domain and range. Those are all things that are going to be affected in the next videos that we're going to watch, the transformations. So make sure you memorize those on those first three. All right, now is where we're going to start to get into trickier problems. So if we first look at y equals the square root of x. In the first problems that we did there, I chose -2, -1, 1, and 2. But are we going to be able to plug those ones in? Are they going to make good numbers for us here? Well, first, I can't plug a negative into a square root, so that's not going to be a good number. So then let's look at the square root of 2. I can't put 2 in there either, so I'm going to make sure I pick good numbers, numbers that I can square root. Well, the first number I can square root is 0. The next one I can square root is 1. Next one is 4, and then 9, and 16. So those are my good square rooted numbers. Those are the numbers that square root out to be whole numbers. So we know when we plug in the square root of 0, we get 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And square root of 16 is 4. Now if you notice, our x's are pretty big here. We get up to 9 and 16, and on my graph, I can't actually get to 9 or 16. So what I'm going to do is I'm going to go by 2's. I'm going to go by 2's on my x values, but I'm going to go by 1's on my y value. So I'm going to label this one 2, 4, and then you know it's going to be going 6, 8, so forth, and then I'm going to go to the negative side, -2, -4. Now one thing you could also do is x's by 2's. Depends on what your teacher wants. Some people label it differently. I like to do the on the number line, they're actually showing it. So I'm going to graph my points here. Now when you're graphing this, one common mistake that folks make is what they'll do is they'll go and they'll make a parabola out of this. So they'll actually turn it there and go there. Now remember, I can't put negatives into my square root. So I actually can't do that. This is my graph. This is my full graph here. So now things get different when I look at my domain and my range. So when I look at my domain, remember my domain is my x's. The only numbers that work for my x's are on that right side, that positive side. I can only put positive numbers into my square root. That means my domain, my lowest number is 0, and my highest number is infinity. So it's 0 to infinity. And my y values, again, I can only do the positive numbers here. So again, we're only going to be looking at the positive numbers. The smallest number that can come out of there is 0, and the biggest number that can come out of there is infinitely large. So again, remember, you need to know what it looks like. You need to know your x's that you usually put in, the y's that usually come out, and your domain and range. All right, let's look at this next example, the cubed root of x. Well, let's think of good cubed root x values that we're going to plug in there. So the first one I know is, well, I can get this cubed root of -8. -8, that's going to be -2. The cubed root of -8 is -2. The cubed root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And the cube root of 8 is 2. Now notice that you're starting on this back side, you're starting to get different x values that you need to put in to make good numbers. That's going to happen, and you need to make sure you memorize which numbers to put in for which parent function. All right, I'm going to graph those points. All right, there's my graph. Now again, let's look at our x values here. Our x values go up and down, and they're going to go infinitely. You can do any x values you want. So my domain is -infinity to infinity. My range, again, we're going to look at our y's. And we can put any y. Oh, I just went backwards, didn't I? First thing I looked at was my x's, or my y, so I looked at my range. My x values are my domain, left to right. So that's my -infinity to +infinity. I was backwards there, sorry guys. All right, next one we're going to look at is the absolute value. And the absolute value, we can go back to our original numbers, -2, -1, 0, 1, 2. So we can go back to our original numbers, and we can get these going in as y is 2, y is 1, 0, 1, 2. Remember, absolute value, that means they always come out positive. It's your distance from 0. Distance is always positive. So let's graph these points. So now your absolute value is going to make a V-looking graph on it. So make sure you remember how to do that one there. And again, remember your x's, your y's. Now let's look at our domain and our range. So first thing let's look at is our domain. Our domain is our x values here. So our x values. Well, what x's can we put in there? We can put any of them. We can put any number into an absolute value. We can put negative numbers into the absolute value. But now our range, that's where it gets different. We can't have negative numbers coming out of our range. So that means that the smallest number that can come out is 0, and then we can go infinitely large. All right, the last problem here. Some teachers aren't going to make you memorize this one. I personally think it's a good one to know, and it's called the step function. And it's kind of blurry and kind of hard to see what this looks like, so I'm going to write it bigger for you. It's y equals, and then it's kind of like a double bracket with the x on the inside. And really what a step function does is that means that for every x or y I put in, I'm going to round down or to a lowest number. So what that means is if I put in 0.5, I'm always going to round down. So if it was 0.5, I'd actually get to, so if x equals 0.5, I'm actually going to get 0. If x equals 0.9, I'm going to get 0. If x equals 0.1, y is going to equal 0. So really, you're going to end up with something that looks like that. And then once you get to x equals 1, that's when you're going to go up, and it's going to end up making a little step function that looks a little something like this. And it's always, the right side are going to be open for this function until you start doing some transformations. So the right side stays open, the left side is closed because you're always rounding down, which means you're always rounding to the left. So this is what your step function is going to look like. Now if you want to learn more about the step function, you can go ahead and you can look online, find a lot of great stuff about step functions, but this is all I'm going to talk about for those with our class. So just remember what your step function looks like. All right, your domain and your range. Well, if you look at your domain, again, your domain, that's your x values. What x values can I put in here? Well, if you notice, I can put any x value I want in here. So my domain is negative infinity to positive infinity. Now is where things get a little bit confusing because I can only get whole numbers, but I can get both positive and negative whole numbers. I always end up, my y values always end up a whole number, but it can be a positive or negative one. And remember what we call those are, we call those all integers, or we call those integers, and so our range is all integers. So we can actually just write that for our step function. All right, those are all the parent functions I need you guys to memorize how to do. You are going to need to know how to do those ones by yourself, by heart, basically. Next video, we're going to talk about some of the transformations that happen.